the topic for this video today. So this is when this is the big reason why I had you always write dy dx and never write y prime, and this is when it will make your life easier. So normally we have been doing all things that were solved for y. So the left-hand side was always just dy dx because the derivative of y with respect to x is just dy dx. So everything was already solved, y equals something in terms of x. But there are oftentimes we have equations like this that are either they're not solved for y because either it would be impossible or at least extremely difficult, and it's much easier to deal with written as it is, so that we call that implicitly. So every time we've been doing the derivative, we have always been doing the derivative of the left and the derivative of the right. We've always been doing the same thing to both sides. But our left-hand side just happened to be plain y, so we just got dy dx. Well, when I'm finished with these equations, I still want it to say dy dx equals. So I'm still going to do that. It's just that I'm not going to get directly dy dx on the side. Okay? So the key is, the way I've said this all the time in class, is, it's the derivative of y with respect to x. Okay? And that's important because if the variable you're doing the derivative of is directly x, then you're good. But if what's inside that is not plain x, then you have to use the chain rule. Okay? So we're going to look at, there's some steps, but they'll make more sense after we do the examples. So first example, we want to do dy dx for this problem. So I'm going to actually rewrite the problem a little bit, kind of spacing it out. You'll find it a little bit easier for you to do if you'll do that, because it kind of helps you follow what you did. So now, instead of solving it for y, I'm just going to do the derivative from left to right, both sides, just like I would anything else that we do for solving. Okay, so when I look at the first term, first thing I need to notice is that this is a product. This is the product of x times y. So we must use the product rule. And if you start to get confused about the product rule, you've got to really fix that because it's going to cause a lot of issues. So this is a product, so we use the product rule. So we do first times the derivative of the second. Now, the derivative this time, it's the derivative of y. Well, we're doing this with respect to x, so literally just say to yourself, okay, it's the derivative of y with respect to x. And there you go, that's the derivative. Okay, plus the second times the derivative of the first. Well, the derivative of x with respect to x would just be 1. I don't need chain rule because it is the variable I'm doing it with respect to. Okay, so that's just the beginning. That's just this part is this derivative. Now I need to do the next one, which is y. So I need to simply take the derivative of y with respect to x. And so that would be dy dx equals, and then I have a constant. Well, the derivative of a constant is 0. So I have my derivative, but when I'm done, I want it to look just like it's been before. I want it to say dy dx equals, not this mess here. So I'm going to combine the terms that say dy dx over here on the left, and I'm going to move the term that is not dy dx over to the right. So that's this term, so that'll be minus y when it moves over here. Then I need to solve for dy dx. So that means I need to factor out dy dx from these first two terms and write down what's left. That would be x plus. If you have difficulties doing that, factoring like that, you need to always put a 1 there so that you can see that what's left is x plus 1 equals the opposite of y. The other thing is, if I factor something out, I can check my answer by multiplying it back, and it has to be the same. So dy dx times x is this first term, and then plus dy dx times 1 is my second term. So if you accidentally just do like dy dx times x, you'll see that you don't get what you have above. So kind of check that if you struggle with that a bit. Now remember, I'm solving for dy dx, so I'm just going to simply divide by x plus 1. So I get the opposite of y over x plus 1. And I got an expression for dy dx. Now, difference here is this says find dy dx at the point 3, 2. So this is, again, some important notation. This is dy dx. I found that. Now I have to evaluate it. So I need to write dy dx, and then remember that vertical bar. And then since it's an x and a y, just put the point there. So I'm evaluating it at 3, 2, and I simply plug it in. So it's the opposite of y, so -2 over x, which is 3, plus 1, which is -1/2, because it would be -2 over 4, and I'm finished. And remember, this is the one time that I'm going to tell you it's okay to do horizontal math, okay, when it's a one arithmetic thing, one step, okay? But that's the only difference. If it asks you to evaluate it, you still do the same process and then you plug it in. Now, I will say sometimes if it's really, really complicated when you finish your derivative, then you could leave it, plug the numbers in, and then solve for dy dx, but I want you to practice this algebra, so we're going to just always go ahead and solve it most of the time. We will, I should say. So again, I'm going to kind of rewrite this so it's a little bit bigger and spread out so I can kind of keep it lined up a little better. And you're just going to work left to right all the way across, just like any other solving. So first, I'm going to do the derivative of x with respect to x. So that will be 1 plus. Now I have, again, a product. And 3x is going to be my first term. I just like to put the constant with the beginning. Oops. And my second term will be y. So I'm again going to do this product rule. Now, if it had been minus 3xy, I would have wanted to put minus big bracket and then do my whole product rule. So don't mess up on my signs. But since it's addition, I'll just go through it. So I'm going to have first times the derivative of the second. Well, the derivative of y with respect to x is dy dx, plus the second times the derivative of the first. The derivative of 3x with respect to x is just 3. So now that product is done. Then I have minus 2y squared. So power is the outside function, so I'm going to get minus 4y, leave that alone, lower the power by 1. But now I have to do times the derivative of the inside because the inside is not x. So times the derivative of y with respect to x. So here's again where the chain rule comes into play and why it's so important for you to have always had that dx in the bottom. Because this is not x, so therefore I have to do that times that derivative. And then equals, and now I do the derivative of a constant is 0. So I'm going to do the same thing. I'm going to put together the two terms that go with dy dx, and then I'm going to put the other stuff on the other side. Now, normally I tell you to try to keep your equal signs lined up real well, but it's kind of hard to do it on this because I have a bunch of terms on the left and I'm going to move half of them to the right. So for this one step, we'll not be lined up, and then we'll line up from then on. So I have 3x dy dx minus 4y dy dx. And then that's going to equal -1 minus 3y, because I have to move both of those terms that do not have dy dx over to the other side. Then I can factor out dy dx, and I'm left with 3x minus 4y equals -1 minus 3y. Now, you could go directly from this step to this step. But don't do it if you start making mistakes. But people that can factor out and combine those terms, that's fine. You can skip right to that step. And then I have dy dx equals -1 minus 3y over 3x minus 4y. Now there's all kinds of things you might be able to do to simplify that, but there's no point in me doing that because I'm supposed to be evaluating this. So I want to find dy dx evaluated at 1, 1. And so I'm going to plug in easy here, 1 for x and 1 for y. So I have -1 minus 3 over 3 minus 4, which is going to give me positive 4. So that's going to be my derivative evaluated at 1, 1. Okay, now we're going to do a whole bunch that we're going to really not evaluate at anything. We're going to do several of them, and so again, we'll practice that algebra. So for me, again, I like to write it out. You don't necessarily have to do that. I just don't like when stuff is typed, it's kind of small, and I want to sort of spread things out a little bit so that it's a little easier for me to sort of have lined stuff up, I guess, kind of. So I'm going to go ahead and do the derivative left to right. So first one is y cubed. And remember, I'm taking the derivative with respect to x. So that means power in front, leave this alone, lower the power by 1 times the derivative of the inside, which is dy dx, because again, it's not x, okay? Plus, then I have 5y squared, so again, use the power rule. So I have 10, leave this alone, lower the power by 1 times the derivative of the inside, minus 5y, so I get 5 times the derivative of the inside, because again, y is not x. I'm doing it with respect to x. So this will have to be times a dy dx, minus, now I just have x squared, so that's just 2x, because that's kind of our normal, and then equals the derivative of -4, which is 0. So now on the left, I can put together my terms and I can factor out. So I'll show you what I mean by just doing it in one step. I know that these 3 terms all have a dy dx in them. So I'm going to factor out the dy dx and then just write what is left. And then go ahead and move the 2x to the right. Okay? And so, and I'm going to move that over a little bit. Like I said, sometimes you have to kind of give up on matching keeping the equal signs lined up for one step there. And all I do is divide. So it's 2x over 3y squared plus 10y minus 5. And I'm finished. So you do need to go to the point of having dy dx. And then you know that you're done. And that's it. That's the answer. All right, so now we have another one that says find y prime, again, which means dy dx. So unless you're told otherwise, it means dy dx. So I have on the left, I have y times e to the x, and on the right, I have 3 pi, which is a constant. So on the left, again, I have a product. I have y times e to the x. So again, helpful to say times when you say that in your head so you remember. So product rule. So I have first times the derivative of the second. E to the x is the easiest derivative. It's just e to the x times the derivative of the inside, but the inside is plain x, so we're good. Plus the second times the derivative of the first. Well, the derivative of y with respect to x is dy dx. And then that equals 0. So I'm going to have e to the x dy dx equals y e to the x. So I'm going to have dy dx equals, or sorry, minus y e to the x, because I subtracted it to move it over, so that's minus. So I have minus y e to the x divided by e to the x, which ends up being just an opposite of y. So this is what dy dx equals. Okay. All right. Let's go to the next one. Oh, that must be on there twice. Oh, that one got left on there fixed. So let me add a page. And we'll do example 5. So we have cosine of xy equals x plus 3y. Okay, so we're going to again follow the derivative from the left and the right. Okay, so when we do cosine of xy, we need to recognize, and it doesn't hurt if you want to put parentheses so you kind of see your inside. Well, the inside is a product, so just don't forget that. So first thing we do outside. So first we have to deal with cosine. So the derivative of cosine, it's a co-function, so it's negative or opposite of sine of whatever, leave it alone. But that whatever, leave it alone, is definitely not just plain x. So we're going to have to take times its derivative. So the derivative of the inside is a product. You have a first term and a second term. So you're going to get first times the derivative of the second, derivative of y with respect to x, plus the second times the derivative of the first, and the derivative of x is still just plain 1, okay? So it's still going to be 1 even though it's implicit because it's with respect to x, okay? So we have that. Then on the right we have the derivative of x, which is 1, plus the derivative of 3y, which is 3, but since y is not x, we have to do times dy dx. So now we're going to have to do some distributing on the left to get our terms so that we can move things around, and then we'll move things. So if I multiply first two terms together, I'm going to get minus x sine xy times dy dx. And then I'm going to have minus, because I do this one, I get negative, and then it'll be y sine of xy. And that's just distributing on the left, and then the right is still just 1 plus 3 dy dx. And then I need to put my terms together. Now this time I have dy dx on both sides, so I'm going to move the dy dx terms together on one side, and it doesn't matter which direction you move them. So I can move in either direction to put them together. Okay, so I'm just going to move left for dy dx's and right the other way, but it doesn't matter. So left will be minus x sine xy dy dx minus 3 dy dx, because I have to move this one as a dy dx, equals, and then I have the 1, and then I'll have plus y sine of xy. And remember, this is a video, so you can always pause and slow down and make sure you can follow that. Then I have dy dx that I want to factor out, so I'm going to be left with minus, or an x sine xy minus 3 equaling 1 plus y sine xy. That's not changing on the right. And so now I can solve for dy dx, and I'll actually just write the answer this way. It's going to be 1 plus y sine xy, that's what's on the right, divided by, I have to divide by this one. And there you go. Now, if you look up an answer and it doesn't match, okay, I would leave the answer, but if it doesn't match, you might see it written negative 1 minus y sine xy over x sine xy plus 3, and that's because they simply factored out the minus in the bottom and moved it up to the top, made the top negative and the bottom positive. But again, as long as you get to the point where you can match it, you're good. And then definitely if I was plugging numbers in, no point in doing anything else. Just go ahead and leave it. Okay, so example 6, we need to differentiate this. So we have ln of xy equaling sine x. So again, we're doing the derivative with respect to x. So on the left, we have ln of xy. So that means the outside function is ln. So remember, I told you to memorize the formula for the derivative of ln as du over u. Well, as soon as I realize that is when I should actually notice that I want to use log properties first to make life easier. Because I could do that, but the derivative of the inside is going to be a product. And logs have these amazing properties that the log of a product is the sum of the logs. So that will make my derivative much easier. If you don't notice that, then you're going to do a longer process and you'll still get to the answer. But again, we're trying to learn some efficiency here so we can make life a little bit easier. So when you have logs, if there's a log of a product or the log of a quotient, then you need to go ahead and do that if you can so that you can use your properties and make it easier. Now it's much easier. The derivative of ln of x is just 1 over x. The derivative of ln of y, well remember, we're going to think of it as the derivative of the inside over the inside. So that's going to be dy dx over y. Because the derivative of y with respect to x is dy dx, and the derivative of y or over y. Then I have the derivative of sine x, which is just cosine x. If the x is inside and you're doing with derivative respect to x, then you just write it down the same way we've always done it. So that makes life a little easier. So at this point, I would do two things. I would get dy dx by itself, and I would rewrite this as 1 over y times dy dx, because that's what it means. And then I would also subtract the 1 over x and move it to the right. Then I need to solve for dy dx, so just make it dy dx equals, and then just do y times negative 1 over x plus cosine x. Don't waste your time distributing the y and doing stuff like that, because again, you can match that if you see an answer that's written that way. So make it easier. It's just y times both sides, so y times that whole thing. Okay, we're going to do this example, and then we're going to leave the last two examples to do in class as a review and kind of a practice together. But this is a good one because this is going to tell us to get the equation of the tangent line. So regardless of what anything looks like, as soon as something says equation of the tangent line, you need to remember to write an equation of a line. I need slope and I need a point. Well, they gave me the point. It's a tangent line, so the slope is found by the derivative. And by that, we mean dy dx. So you have to solve for dy dx, okay? So we're going to do this derivative left to right as we see it. So derivative of x squared with respect to x is 2x. Minus, and here's where I would do minus parentheses, because I have to distribute and do this as the first term, and this is the second term, and I want to be careful with that y. The other option is make the first term negative x, and just make sure you keep that track of that. It's up to you what's easiest. I like to do minus parentheses. Now I can ignore the minus and just deal with just the x and the y. So now I'm going to do a product rule because it's a product. So it's first times derivative of the second plus the second times derivative of the first. Now notice I could just do plus and everything because again I put the minus out here and then I don't mess myself up and I left it alone. So that's done. Now I have to do plus this derivative, which is power in front, leave this alone, lower the power by 1 times the derivative of the inside, and then this whole thing equals 0. So we're going to combine some terms, move some things, different stuff. So I'm going to have, and I'm going to move down a little bit so I'm below that graph. So I have 2x, I have minus x dy dx minus y plus 2y dy dx equals 0. So now I want the dy dx's on one side, and again you can go ahead and factor out the two things that go with dy dx by itself, and then on the right you're going to have to subtract 2x and add y to get them moved to the other side. So now dy dx equals negative 2x plus y over minus x plus 2y, because I'm going to divide right there. Okay, so now that's just the derivative. So this is the equation that gives me the slopes of the tangent lines. It is not the tangent line, and it is not the slope of the tangent line. It's the equation that gives me the slopes. I want the equation at negative 1, 2. So that means I need to find dy dx evaluated at negative 1, 2. So I'm simply going to plug that in. So I'm going to have negative 2 times negative 1 plus 2 over 1 plus 2 times 2, which is 4. So my slope is going to be 4 over 5. Okay, so there's my slope of the line. So the tangent line is going to be y minus the y value. Well, the point was negative 1, 2, so that's the y value, equals slope times x minus negative 1, which of course we write x plus 1. Only thing that I would ever do even a little bit different is you could just put plus 2 on the right instead of y minus 2. But I would leave it alone. That's the equation of the tangent line. Now the next question says find the equation of the normal line at that same point, negative 1, 2. So the normal line, which is not actually tested on AP, they don't ask that, but just so we know it, it's the line that's perpendicular to the tangent line. Okay, so we know that if a line is perpendicular, the slope of a perpendicular line to 4/5 would be negative 5 over 4. So the equation for the normal line would be super easy. Because we wrote it in this form, it would still just be y minus 2, but it would be negative 5/4 instead of positive 4/5, and that's it. That would be the slope of the normal line. Now if we go back and look at this graph, so here's an example of the figure that we might get, or that we do get, for x squared minus xy plus y squared equals 7. It's an ellipse that's been rotated. We're not going to get that far into conic sections, but if you look at the points that we said, we're at the point negative 1, 2. And if you were to take your ruler and draw a tangent line, you would be able to see that being reasonable to have a slope of 4/5. Okay, so you can draw that. So this would be the tangent line. Again, if you use your protractor, it'd look better. And then the normal line is simply perpendicular to that. So it would be the line that goes this way. Okay, and that would be the normal line. And so that's what that would look like if you were graphing them. So that's what we're talking about, is a tangent line on a figure that's not a function. Okay, so it's an ellipse. So again, we'll finish the rest of this in class. So that's it for this video.